Hello everyone, I hope you are having an amazing time. So today we will be learning about LangChain fundamentals. So in the last session we basically completed one uh, you can say chat bot with structure, which means that there was a summary and confidence which was uh, being returned. So just a second. So yeah, I hope in this like uh, session we will be able to understand about the LangChain fundamentals, as well as we will be continuing with whatever follows up. So let's start without any further ado. We were here, and if you see my git status, then I am on main branch. I have already pushed it to my GitHub. So this is the UI as well as back, like this is the UI. So if you see, we also have backend. So if you see git status here, we are also nothing to commit, work tree is clean, we have already pushed it to our backend. So yeah, so if you allow me, then we should now continue with LangChain fundamentals. So why actually we need LangChain when we actually have something called a raw SDK already present? So why actually we need LangChain? So in this case, you must be knowing why exactly we need LangChain. You should be knowing by now that raw SDK is probably related to low level calls. So raw SDK, low level calls, but if we need something of higher level where we need a structured output, then we should use LangChain. We should not build a framework from the scratch, rather we should leverage the framework, as they say. In some of the cases you need to build a framework, of course, but if it is not required, which is in most cases, so we can do this. It is easier to switch models and compose. As you saw, we already used so many models, so we were not stuck to one model in that code. Let's say I'm using something called OpenAI, of course, which is already present. So I will go with openai.chat.completion.create might be a function, and then I will do something there. So now that's gonna work for tiny demos. So assume we have some requirement. My requirement is I need to have a multiple model provider. I also need OpenAI, Gemini, Grok. So I can count on multiple LLMs. So based on whatever is present, that is our requirement. So user will be having an accordion, and on click of any options from the accordion, you will be having a feature to choose whichever model you want to choose. So in that case, and you in a case where you need different tools, in case where you need different racks, in case when you need different tools, racks, and different retries functionality, okay, logging and all this you have to write it from scratch, and when you refactor that code it will be hefty on your part. So now LangChain comes here. So LangChain actually is a toolkit that gives you all together in this package. So it will be abstracted, of course. It will not be like something like sharpen where you can change whatever you need, but it will be an abstracted code which will allow you to use these tools, these racks, these retries mechanism, as well as all it almost allows all the models. And yeah, so this is why we use LangChain over an SDK, because we are not chained, we are not stuck to one single LLM. So we have something called LCL. So assume you can consider this as a pipeline. So you can compose different functions together here. So we'll understand about this. So this is the difference why we need LangChain. So it actually gives us a toolkit which a raw SDK won't give. So I hope you understood about this. The reason we need LangChain, this will make things clear. This point, these 3 points, I think. So LangChain, of course, is a shared pattern. Everyone uses this utility. It's just like you can say it's just like not using vanilla JS and using React JS for things. You can say that it's a frame, like it's not a framework, it's actually a tool. So yeah, maybe it's a framework, I don't know. So easier to switch models and compose flow. As I said, you can use multiple models, LLMs. Let me check if my voice is audible or not. Yeah, it is pretty much audible, guys. So we need to understand the core building blocks of LangChain first. So the thing is with me, it is that you need to be really slow and you need to have some patience in order to understand these concepts. So please bear all this. The core building blocks. Now if you see that the core building blocks, now if you focus on the core building blocks of LangChain, so you will get to know that there is one pattern of it, which is prompt. Of course, prompt, and that is what to ask plus how to ask. The next thing is a model, of course. So which LLM do we call here? Okay, so there is another small thing, not a small thing, of course. the output parser, which means that turn text to whatever data which is required, okay, which we did earlier in the session 3. If you focus on the session 3, these are the 3 things that we did, and we don't need to like do it again and again, but just a quick recap. The prompt that we did, which to ask for how to ask, was inside our localhost 3000, which is like our front end. Of course, we asked about something called Docker. So what it did, this is the first step. Now LLM, we set our LLM to grok from the provider code, so it was giving grok in that scenario. Assume before this we would have passed this grok through params, and it would have gotten, okay, which one to choose. So we already had options for OpenAI, okay, we already had another option for Gemini, okay, we already set the grok, we already had option for Anthropic, the code that we did earlier. So we choose grok because it is free to use at this time of doing it. I don't know in future what it will happen, but the llama model was free to use, so we use this in our env.env providers. We put this grok thing, so that is why this LLM was working. Otherwise, if you need to choose it from the front end, then you just pass it as a param to the back end. Now the output parser turn text, whichever the text will be recognized. For example, in our lang chain, we created a new model, right, out of it. This model, what it did was it returned some string. So, but what we did, we invoke a pattern, a type of JSON. So that JSON is this. It turned out text requirements. So that's what. No, I think I should keep it. No, leave it. So you understood about this, right? So this is what it is. Oopsie. Okay. So invoke method was used in order to get this type of data. We already had it in a schema, and it was Zod which did that, and we took the type. You can write it if you are doing notes. It will help you out in figuring out where you were in the last session. I make notes in digital as well as analog method, so that I can recall it. It can help you a lot. So the output parser, of course, turn text data which is required, of course. These 3 are the core concepts that we need to understand. Prompt is actually not just a string. The prompt, it is like a template. First one is the system rule, like we used to assign an assistant or whatever. Second one is the instruction, and third one is the placeholder for variables, if you have some queries or context. We want the prompts to be predictable, reusable, and easier to read, of course. You have the UI, you have the orchestration, which is the lang chain. this case it will work here. So if you consider that this chat model wrapper will swap the provider with minimal changes, let's for example we are going to change from OpenAI to Gemini, we can easily do that. So it's gonna help us to attach different kinds of configs. For example, temperature we can add on top _p, max token, which we already discussed. So this will be the model which we need to decide which model we need to call, and the third one will be the output, which means we don't want to manually pass the random text. So we need the output say as a JSON format. We have already discussed about it, so I'm not gonna repeat it again. So for structure output we're gonna use sort. So we had the schema, right? LLM processed it and the LLM understood that okay, I need to process this particular query, and based on that I need to make this structure output with .invo. These three concepts are very important. So prompt, model, and output parser. So the runables and LCEL. This is the next thing. So we will understand about something called runables and LCEL. This is like, okay, let's write it down first. This is the full form of LCL, guys. Langchain Expression Language. Runables are actually a generic unit of work that can be invoked, batched, or streamed. A lot of other things that you can do as well. So you need to understand the simple idea. So each step in our LLM pipeline is a runnable. Each step in our LLM pipeline is a runnable. Okay, so you need to write this down. Each step in our LLM is a LLM pipeline. Okay. Each step in our LLM pipeline is a runnable. This is pretty important, guys. Generic unit of work that can be invoked, batched, streamed. LCEL, Langchain Expression Language, and the last thing is each step in our LLM pipeline is actually a runnable. So if you want to understand what runnables are again, then runnables actually things that takes input, does something, and then gives output. Okay, this is something about runnables actually. Runnables actually are things that takes input, does something, and gives output. So this is the thing about runnables. Okay, also about this, yeah. So yeah, correct. If you go to LangChain SDK, then you will see one thing. Search for something called class runnable. I think this will reference LangChain. How do I show you runnables? Okay, I'll do it this way. Reference. I don't think it will open, but still I will do it for you guys. Have patience. Okay, classes LangChain core dot runnables. Cool. Yep. So this is the one. Runnable is a generic unit of OR that can be invoked, batch, streamed, and or transformed. Okay, guys. So type parameter run input is any, run output can be any, call options extended runnable config baseline. There will be a lot of things. From here we will discuss about runnable sequence and runnable map. So I read a runnable sequence and enable map. Consider you're creating a particular agent where you're gonna have a prompt template. So that prompt template is a runnable. So based on that prompt template, you're gonna do a module call. So that is also a runnable. It's like a sequence that you're having. Assume you are at step 1. Then step 2, step 3, 4, step 5. So every step is actually a runnable. It's like a chain. So if this is the case, then where does the LCL comes to picture? So LCL helps me to see these runnables in a clean way. Okay. Oh my god. It's been like 20 minutes and I'm not sharing my screen. Anyhow, I'm in the compound. So this is where we were earlier. You can check this out. Why actually we need LangChain, raw SDK, low level calls, LangChain shared with patterns and utilities, easier to switch models, compose different functions together, core building blocks of LangChains are prompt, what to ask and how to ask, model which LLM we can do. So these are the things. Which LLM we can call. So these three things are of course the core building blocks of LLM. The runnables and LCL are one of the important concepts of LLM. So generic units of work that can be invoked, batched or streamed are runnables, which means that there are different steps in an LLM call. So every LLM call steps LC. Runnable is actually a thing that takes an input, does something and gives an output. So most of the functions, most of the batches inside it will do the same. It takes an input, does something and gives an output. So already I showed you here that the runnables are like this. So these are the classes of runnables: raw inputs, run outputs, and these are the two things that are important here: runnable sequence and runnable map. So if you go here, then you assume these 5 steps of LLM are runnables. So the thing that chains them together is then LCEL. LCL is LangChain expression language. So LCL helps you to chain these runnables in a very clean way, which means these are also called pipes. So if you want to chain them up together, then it will help in a certain way. Yeah, that's all. And yeah, we were in that particular uh, flow. I'm really sorry I was not sharing the screen all this time. So LCL composes of different functions together. This composes different functions together as a LCL. Okay, the LCL composes different functions together. So these are the functions which it was mentioning. So step 1, step 2, step 3. So runnables are you can say the generic unit of work that can be invoked, batched. They can be batched together as a one unit and streamed. And they are also something which can be transformed and or transformed. Okay. So these are the things the LCL already I mentioned you that they chains together all these runnables. So if you see that the step 1 is the input of step 2. Okay, my bad. Step 1 is the input of step 2, step 2 is the input of step 3, it goes like this. The input that C needs depends on, I assume that inputs that step 1 needs depend on step 2, step 3. These are not steps actually, these are A, B, C, D, E, F, whatever. Like you can understand from whichever sequence or patterns. But I hope you understood. First you do step 1, then you do step 2, then you do step 3, then you take the step 2 as an input to step 3, and do step 4. So it's gonna run multiple branches in parallel. So you have to consider that these two things are runnable, the simple functions these are. So the runnable sequence is like each and every sequence is gonna run, but a sequence will be dependent on the previous one. Pole sequence or the first sequence will not be dependent, but the last one or the next one that proceeds it will be dependent. So this is what it is. So we'll start our journey with the projects. Give me a second, guys, let me check if the stream is working properly. Okay, guys, so let's continue. We're going to build something now, and I'll show you the architecture of how we're going to implement this in details. So we'll move to the next section pretty quick. So I'll give you the project overview right now. So the first project will be a web agent. So the first project will be a web agent, of course. So earlier what we built was with the help of LangChain. We asked something and we got some structured output. So the first one here will be project web agent. So we will be using LangChain and Tableau for this particular project. So in this video I'm gonna give you the demo and how things will work. Not a demo, I will create this thing from scratch, of course. So it will be like this. You ask anything. Okay. So based on your query, this will implement a route strategy. So for you it will be like, for a user it will be like a simple query, but for us the route strategy will be maintained in the backend, and based on that the LLM will decide whether we need to browse the web or we will take it directly from the LLM. I hope you understood. if I do this in front end, ask anything, I am making a query. So this query, if I send to our backend, then it will do a route strategy. So this is the motive of the project. Okay, the route strategy basically. So what that route strategy will do is, it will decide if we need to go to the browser in order to fetch more context about it, or we already have this particular context in the LLM itself. So for our web browser, actually we'll be using Tableau. Okay. It's not like we are going to directly get the answer back. It will be with the help of Tableau, and it will be structured actually. So it is like it is going to fetch some pages, relevant pages. It's going to create a summary, and based on that summary, we are going to get the answer back. So we can't think that we are directly getting the answers back, whatever is present. It will create a summary, and at the same time we are going to get the citations or the sources back. This is definitely going to take some time because it is going to go through Tableau. It is going to delete the unnecessary data which it has scrapped from the web browser. So it will give you the first 6 results with the score. So it will give you the real sources also. This is amazing. Oh, this is actually from where it will collect the data. So this is the project that we are going to build. So it will also give you the references from which it took, I mean the websites from which it took. So we will build this website now. So the name of this project will be Route Strategy AI chat with route strategy. we will open this one. What we will do is we will create one Scalidraw. So if you see here, I already have this extension, so it is working here in my VS Code. So if you see, what we are gonna build is like this. So Next.js UI, of course, which we did earlier, and a post search. This will be a post search, post call, of course. The backend will be, of course, our TS, not JS this time. Okay, so we'll check if it's a valid input. So after that valid input, it will go to the route. So if it is web or direct LLM, I hope you understand. This is direct, this is web. So we'll keep it a little straight. Web search, direct LLM. Okay, so we'll use stably search top K23. So I'll write it for other web search. This thing that we will be using, stably search top K 2 to 3, we will give top K. Okay, as in like top P we did, right? We can filter, because this will, what it will do is it will pick and it will filter. Chain is like a step, and every next step is dependent on the previous step, as I said. So first step is to validate the input. So step this route is going to have a strategy. Either it is going to be a web path or a direct path. When this route strategy identifies that, okay, this query LLM already knows, so in that case it is not going to get to the web path, it is going to go to this path. It is going to validate with sort, and it will return this output what it used to give in our previous project. But for web, it is going to use this. Now pick and filter, then it is going to give the sort validation, and then it is going to give the output. So it also does one more thing. Open and summarize many of them. Tabili is actually a web access layer, which is actually going to give us a search API. So using that search API, we're going to get an answer back. We're going to get our sources back. So assume give me top 10 teams in World Cup qualifiers or World Cup finals, probably. So this is where your web search comes in this case Tabili will come in, and it will pick and filter, then open and summarize and compose final. Then the Zod validations comes in. Then the output. Actually what happens is when it composes final, it removes all the unnecessary information and pick and filter part. Then open and summarize from that. So it is gonna pass it to the next chain. So if you see, these are probably all the chains. Each chain helps in composing the final answer. So this will be the flow that we are going to implement actually. Okay. This is not all about the search API that we are creating, but this is applicable for any agent we are gonna build. So assume we are building an e-commerce agent or support agent. So in those agents we are getting a query, and that query our LLM already knows. So in that case, instead of going to the web every time, web path is of course costly. We have to spend some money on in terms of the API. So if the LLM already knows, why do you need to go to the web path? We can go to the direct LLM and we can give the answer if it is simply present in the LLM. So we can give the answer from there also. Give me 1 second, guys. Sorry guys to keep you waiting. Actually, I was having my dinner. This is quite important for me. Guys, if you notice this one thing right here, so actually I'm having so much pain on my tooth, so that is why I'm unable to actually speak today. I was thinking of taking a break actually from streaming. That's why I streamed late today. Rather, I would have done it in the evening. So I was thinking that I should call it a day actually, because if I keep on if I keep on continuously talking on this, so it will it might increase in terms of the pain, and it might get to a worse situation. So I'm really sorry, I can't help it. So we have to stop this session. We'll continue to build this particular thing code wise from the next session as well. No problem, because I'm already here. So that's all. I'm really thank you for to you guys for being there, whoever is. Particularly it's a new channel, so I think nobody would be here, but if ever you have come here at any point of time, then thanks.